Alrighty, we talk a lot about inverses. Algebra is really important to know our inverses. Why? Because we need to know how to undo things. The opposite of plus is minus. The opposite of minus is plus. The opposite of times is divide. The opposite of divide is times. The opposite to taking it to the power of 2 is the square root. The opposite to the power of 3 is the cube root. The opposite, and vice versa, the opposite of the square root is squaring. So it's really important to know our inverses, and in this case I'll even put in just one more, which is to the nth power is the nth root, and vice versa. Alrighty, so there's some functions that we don't know the opposite to. The opposite of plus is minus, we know that. So what's one that we don't know? Well, what is the opposite of sine? Well, the opposite of sine is sine -1, which is usually found shift next to your button. What do we think the opposite of cos is? Well, it's cos -1. What's the opposite of tan? It's tan -1. So it's really important to know your opposites because they allow you to undo things. And in particular, it's going to help us solving for angles. So we now know the functions and their inverses. Alrighty, so let's have a go at actually solving for some of this stuff. Alrighty, so let's draw a triangle. Alrighty, so in this case, I want to find both alpha and beta. And in this case, I know 10 centimeters and 25 centimeters. In particular, we can see 25 centimeters is the hypotenuse. But 10 centimeters for alpha is the opposite, but for beta is the adjacent. I'm just using alpha and beta to represent angles. It's common. The most common one you'll have seen is theta, but it's very common practice for us to use Greek letters to represent angles instead of x, y, and z. If it comes up, just means it's a little bit more comfortable. But alpha is like a curly A, and beta is just a B with a little tail. Alrighty, so in alpha's perspective, well, 10 centimeters is an opposite, but from beta's perspective, it's an adjacent. And it's really important to notice things like that because really it depends on your perspective as to whether something's going to be an opposite or an adjacent. So let's think about from alpha's perspective. We want to think about from alpha's perspective. Well, we know that this would be the opposite, not the adjacent, and this would be the adjacent. We don't know anything about the adjacent, so we don't want to use it. So let's ignore the adjacent, and let's think about our opposite and our hypotenuse and write down what we know. O and H, that's sine, katoa. So sine of theta equals opposite over hypotenuse. And we don't know the angle, so I'm going to write sine of alpha. If you're not very good at writing alphas, you could write just a little a. That would be fine. And my opposite is 10, and my hypotenuse is 25. And you'll notice we're going to have to undo that sign. What's happening to alpha? It's being signed. We need to unsign it. Opposite of sine is sine -1. So we're going to move sine to the other side and use the -1 version of it. When sine moves to the other side, it eats up everything that was on the other side. So whatever was on the other side is gobbled up by the sine -1. And now we just need to type this in our calculator. Just make sure you're using the inverse sine function. And we get our answer. Now it's 23.578, which I'm going to round up to 58. But what units? Well, it's an angle, so I'm going to put the degrees symbol. Now the question is, now I want to find beta. How can I find beta? Well, from beta's perspective, this is the adjacent and this is still the hypotenuse. This is still the hypotenuse and this is now the adjacent. But wait, why would I bother doing that? That seems like a lot of work. Instead, what I could do is I could remember something about triangles. And one fact about triangles is if you add up all of the angles, it should add up to 180. So that means that if we add alpha plus beta plus the right angle, which is 90 degrees, that should equal 180. Except we know what alpha is now. It's 23.58 degrees. So we can work out beta just by doing some subtraction. We don't have to do anything more. Alright, so we should subtract 90 from both sides. and that gives us 23.58 plus beta equals 90, and then we could subtract 23.58. And that gives us beta is equal to 66.42 degrees. Alrighty, and we can double check that by adding this plus the 90 degrees for the right angle to double check that it does add up to 180. Alrighty, so that's how we can use the inverse sign to find angles. But just be mindful, if it's a cos or a tan, you can do the exact same, just with inverse cos or inverse tan. See you in the next one. Goodbye.